Hello. What's going on? Sorry, I'm just going to get a few things set up here. All right. One sec, I got to mute my other machine here. No, I also use IDA a lot. So I'm going to be using that today just because for the past 3 streams I've been using Binary Ninja. I primarily did those streams just because I wanted to get used to using Binja and probably do some core stuff on it at some point. But yeah, I'll go through the chat. Hey, Harvest. How's it going? Hey, Juan. Snowy. Sorry if I mispronounced that. Hey, yo, what's up? Everest, how's it going? Hey, Duncan. Great to see you. So yeah, we're just going to do some beginner malware reverse engineering today. Who's the idiot in the bottom right? Good question. Good question. What's up, Brimco? A part of this stream is going to be us identifying what malware sample this is. So I don't want to spoil it. But if you all want to work ahead, I uploaded this to Malshare. Here, I'll provide the sample in the chat. But yeah, if you want to work along with me, you can download it there. And yeah, I just want to go through kind of every step that's needed in order to, one, identify what the malware is doing, and 2, attribute this to a particular malware family. I think we're doing pretty good on numbers, so we can probably get started. So let me get back to a clean state here. So, okay, so the sample we're going to be looking at, I'm just going to get rid of these dumps because we don't need them, is this 75D hash. And Murtaziat, where can I ask to be technically interviewed for an AppSec RE position? I'm more interested in being interviewed to get feedback than getting an offer. Murtaziat, I think probably your best approach is to, yeah, that's okay, I can answer. So I think finding a mentor or some peers that are in a position that you'd like to be eventually is a better strategy, or finding those peers and then speaking with them about potential mentoring opportunities or where you think you need to be in order to get a AppSec or malware RE position is more fruitful than actually performing interviews for those positions without actually getting offers, if that makes sense. So in our Discord and on the OA Labs Discord, there's a ton of people that are more than willing to help. We don't really have a ton of voice chats on our Discord, but I kind of like to pick that up just so we can have more organic discussions. So I'll probably do more of that going forward. Yeah, the Discord is public. Let me just link it. So I don't have a direct link for the Discord, but if you register here, then you can get access to it. So, I mostly just do that as like an anti-bot thing, just because we don't really want a ton of spam in the Discord. But that's I'll talk about the core stuff later, but I just kind of want to get into the stream. But yeah, if you register on there, there's a Discord link. So, okay, so generally the first thing you want to do when you have a malware sample, so there's a whole bunch of different sample acquisition scenarios that you would have, say, within like a corporate environment or on your own personal computer. For example, you might have on your personal computer, you might have, say, an antivirus detection for a file that you want to determine whether or not it is malware and what type of malware it is. So that's an example scenario. In that scenario, the sample would be on disk, so you'd probably find it in a directory with a run key attached to it or some type of persistence. And in a corporate environment, you have a whole bunch of different acquisition scenario examples for getting malware samples, whether those be an incident response engagement where you have actual incident responders going into a company, carving out files from memory and then acquiring them that way. Or you could also have a number of different appliances and network monitoring devices in place. So classically, you would have like an intrusion detection system or an intrusion prevention system, and those can capture network traffic. You also have a whole bunch of different scenarios where you could carve them on memory or from memory. For example, like Hollows Hunter is a really good tool for doing that, which is good at detecting a whole bunch of different injection techniques. So just as an example, if we go to temp, there's no malware currently. Oh, sorry, I'm in PowerShell, so I need to use $env. So for example, if you do, Hollows Hunter is already on this machine because this is using Flare VM. But if we run Hollows Hunter, okay, this isn't running as admin, so it's kind of a bad example because it can't access a bunch of the processes. But this is actively scanning all the processes on this machine for different common injection techniques and unmapped portable executables in memory, which is very indicative of malware being injected. So this is like another acquisition example. We could probably mess around Hollows Hunter later with this sample, but I kind of want to go through every step of extracting all the stages of this malware from a basic standpoint for you all. So anyways, that's all to say that more often than not, you'll have some way of acquiring a malware sample. And then a lot of different teams will have either dedicated reverse engineers or they'll have kind of folks with a lot of different backgrounds. Say you're an incident responder, but you also do malware analysis. They'll pass the malware sample off to them for some basic analysis. And when that happens, when you say we get just a file that's carved from memory, the 75D4 whatever file, we want to first identify the file type. So the file type, for those of you who are not aware, so I'm just going to open this in a hex editor. Oops, I just used detected easy. We'll use that in a second here, but let's use HXD. So for those of you who are not aware, every file on an operating system typically has what's called file magic. And file magic is what's used to for the file loader on an operating system. It's different on Microsoft Windows because they use extensions because, I don't know, they made that decision a long time ago. But on Unix-based systems and Linux and Mac OS and stuff, they have what's called file magic, and that's used to distinguish a particular file type. So in this instance, from a seasoned reverse engineer perspective, I can already tell this is a Microsoft portable executable. And the way I'm able to do that is because of these bytes at the beginning. So Microsoft has the tendency to always incorporate legacy into basically everything they do. And you can see that through this file format. So they have this MZ header. And this is actually a MS-DOS header. So for those of you who are millennials like me, you might have used MS-DOS back in the day. Yeah, for this particular file type, those are always the first bytes. Yeah, that's correct. And so this is like a really old DOS header that's appended to each portable executable file format. And then you'll see another header that's also appended to this called PE. And this is essentially the portable executable header, which is a part of this file. So when you open this file on Microsoft Windows, so for example, if you can open any file and it'll have any portable executable file like .exe or .dll or even .sys files, you'll have a number of different extensions, but they're all types of portable executables. So for example, if we go to like system32, then we go to like calc.exe, which I'm sure a lot of you have seen. It has the same header or a very similar header to this malware sample that we're looking at. There's some other interesting artifacts that are very good for malware analysts to look at, such as the rich header. This contains a bunch of compiler information that we're interested in, but this is kind of getting into a whole discussion of portable executables, so I don't want to get into too deep, but just to give you an idea of what we're looking at. So when a .exe is clicked on, the Windows operating system has a loader, which effectively knows how to parse this header, parse the information that it needs out of the file format in order to load the executable into memory and execute it. Hey, Jonas, how's it going? So once the file is loaded and executed into memory, then there's a whole bunch of different steps that occur. Those include loading dependencies for that particular portable executable. So if we look at, I'm kind of jumping ahead here. Let's kind of ream this back to the file type identification. Can I test your 2D game? Definitely not right now, but it's pretty cool that you made your own game. We're doing some malware analysis, so we'll keep on topic here. So for file type identification, there's this really good program called Detect It Easy, and this also ships with Flare VM. And here we have a bunch of different attributes that were parsed out of the file format and then loaded into Flare VM. So some of the most interesting ones, or sorry, not Flare VM, loaded into Die. So some of the most interesting ones is we have a compilation timestamp. So this is typically embedded by the compiler or the build system, and this is embedded within the executable when the person compiling the binary is compiling this. I don't believe this was actually compiled in 2014, but we'll take a look at some other samples later to see if this is accurate. Then we have things like the size of image. So this is the size of the image as it resides in memory. So that's different on disks. We can talk about the virtual size and the physical size later. But here, Die has identified a few different file types within this particular file, or a few different attributes within this particular file. So this is what's called a nullsoft installer, which is what's called a self-extracting archive, which is basically just a fancy word for a program that contains a archive. An archive format can be like a .zip file, for example, which is essentially a compressed archive containing multiple files. And a self-extracting archive is essentially a program that will extract every file from that archive, so from that zip file, for example, and then write it to disk. So this is very useful for programs that have their own dependencies, they have their own DLLs, they have their own libraries when they shipped with a computer. And then this is also useful for malware authors because typically a installer software like Nullsoft will have a scripting language. Execution isn't possible, right? Execution in what perspective, Everest? Or from what perspective? So the self-extracting archive, when you double click on this file, I was just going to get to that. So this Nullsoft scriptable installer system that was identified, it has its own embedded scripting language. And once the files are decompressed and written to disk, this scripting language will execute the files that are written to disk more often than not. And then that's used as the, I guess if you were just installing a program, say a legitimate program, then you wouldn't actually need to execute any installer files. But I guess in some instances you would want to execute your own files to do certain tasks or what have you. I hope that makes sense. Okay, so so if we look at, so what's kind of cool about these installers is we can decompress them and then find the files that are embedded within them. So here, I'll just rename this to, and we can actually use 7-zip to extract the files within this self-extracting archive by right-clicking on it, going to 7-zip, and then extract 2. And then basically this is going to do what I described. So it's using 7-zip, which is, for those of you who do not know, it's a archive handler application that can basically decompress a whole bunch of different file formats, or a whole bunch of different compression formats. So in this instance, it was able to decompress this installer. And then if we look at the different files within that archive, then we have a whole bunch of different files here, including this .NSI script. So this is, I believe, compiled into binary, but if I do, okay, yeah. So Dai was able to identify that this was a scriptable installer system. And so this is that scripting language I was talking about. So if we look and scroll down here, then we can see a few different things. There's these load string operations. There's these functions. So it looks like there's 2 embedded files called blindworm.cab and then supersonics.dll that are referenced in this on init function. And if we keep scrolling down here, then it's creating this uninstaller as well, which is within this archive. And that's kind of it. So it looks like we have this call install DLL instruction that's being made with this plugin's system.dll call. And then this system call with the supersonics DLL is also being made. So I believe the system DLL is a part of the NSIS installer ecosystem by default. But this supersonics tetrapody function is very interesting, and we probably want to look at that. And we probably also want to look at this blindworm.cab file. So if we go back here and we look at our self-extracted archive that we've extracted, then we can look in this plugins dir. So that's that system DLL I was talking about. And then if we look in temp, then we can see supersonics.dll and that blindworm.cab file. So if we open up this supersonics.dll in IDA, so for those of you who do not know, IDA is a disassembler. So hold on, I'm just going to move this off screen because I don't want my, one sec. How's everybody doing? Is everything making sense so far? Am I going too fast? Okay, so I just opened this file, that supersonics.dll in IDA. And the paste is fine. Cool, sounds good. And what IDA is this is a reverse engineering suite that is very popular within the malware reverse engineering community, in addition to the vulnerability research community, etc. And what IDA will do is it will parse a given file format and then extract information from that file format. So in this instance, this is a portable executable, and IDA has loaded this and done what's called a disassembly on the instructions contained within this portable executable. So when you have a piece of code that is compiled by, say, a Microsoft Windows compiler, there's a bunch of information that's lost. And the reason that is because it's kind of only meant for human readability. And when it's compiled into code, there is a bunch of optimizations and information stripped away by the compiler, one, to reduce the size of the binary, and then two, to make it faster when it's running. And these optimizations are done by the compiler based on what you've written as code, and it can strip things away and do a whole bunch of complicated stuff. And what you're left with is these machine instructions. And so IDA can go in and try and recover as many machine instructions in the given executable as possible, or as many as possible. So in this instance, we have a portable executable that was parsed, and it is compiled for the Intel CPU architecture. And in this instance, this is compiled for the older version of the Intel CPU architecture, which is 32-bit. So that is just the maximum instruction length. And that basically is used to create a set of instructions that are executed by your CPU. And those CPU instructions are what are referred to as assembly. So we're looking at the assembly instructions for that portable executable program. And since we already know this is malware, we don't really have to kind of look through this and make sure that this is not a legitimate program, but that's another step that you would typically do. Not contain for Itanium. I'm not sure what Itanium is. Is that like a mobile platform or something? LavaVex. Okay. So let's look at some of this code. So malware code is typically obfuscated in some way, shape, or form. And that's to prevent the reverse engineer, which is us today, from recovering the instructions and therefore recovering the exact functionality that the malware is doing. So in this instance, we have the, oh, cool. I didn't know that. That's cool. I didn't know Intel also made a completely different processor architecture that was 64-bit. That's interesting. So if we look through here, there's not a whole lot we can glean from this, but so IDA has two different views for looking at these assembly instructions. The first is this linear view, which everything is basically delimited by these types of instructions. So for example, a jump here. And these are what's referred to as basic blocks. And the execution flow within the application is what's called control flow. So you'll probably hear me refer to the execution flow or the direction in which this is executing as the control flow from time to time. And these delineated basic blocks basically make the readability of the assembly quite a bit easier. And we can go into what's called the graph view by hitting spacebar. And then this gives us the control flow between all of the basic blocks, and it makes it quite a bit easier to read. So some people like the linear view a lot more. I will use both because there are scenarios that the linear view becomes harder to read, and then there are scenarios such as this one where this function is quite huge, and it is kind of complicated to read. So I should have also mentioned when we open this binary, IDA put us within what's called the entry point function. So if we look at detected easy here, detected easy also has the ability to identify the entry point address within a given binary. And it also has the base address. So this is the address at which the binary would like to be loaded in memory. This isn't guaranteed, but the entry point address is relative to this base address. So IDA has essentially mapped the portable executable into memory. So this is actually a different binary. So let's look at the one from the archive. So supersonics.dll. And as we can see here, IDA effectively maps the binary into memory. Its views within its reverse engineering application are effectively how the binary would look in memory, or how the instructions would look in memory, if that makes sense. So if we were to open this in a debugger, like x64 debug, we need x32 debug in this instance. So shout out Duncan, if he's still here, for creating the best malware debugger in my opinion. And say we open this DLL, there's some more nuance to this because sometimes DLLs need what's called a host application to load a DLL, but for the sake of simplicity, I'm just going to open this. And x64 debug makes this really easy in that it ships with a host application that can be used to load DLLs. So as you can see here, this host application DLL loader has already been written to this location that supersonics.dll was in. And if we hit run, then we can see a breakpoint has already been made at the entry point address within this DLL. So as you can see on the left-hand side here, these addresses match what's in IDA. So if I move this to the right-hand side and then open this up, then we can see that 10506B, if we go to DLL entry point, then these match, right? So IDA is effectively trying to, yeah, I know this, this version old. This is just like a development machine that I've been, or not a development machine, but this is just a an older machine. I need to like literally rebuild an entire, I'm going to build a Windows 11 analysis VM, but I just have been lazy. So, so that's all to say that IDA effectively maps the portable executable into its database as it would reside in memory based on attributes that it extracts that we can see in Detect It Easy. Okay, now, another important thing that we typically want to look at when opening a portable executable to see what functionality could be executed by the portable executable is its dependencies. So on Microsoft Windows, there are a whole bunch of different APIs that are commonly used by malware authors in order to perform certain functionality. So in this case, IDA has parsed out the dependencies, which are in this imports tab. And as you can see, there's very few of them. And these are being loaded from the Windows library called MSVCRT. So it's good to have an idea of what imports are being used because they can give you an idea as to what functionality is being carried out by the malware. But in this instance, there's not a whole lot to go off of. Unsurprisingly, there's use of malloc, which is just for memory allocations, free, and a few other things. But as we will see, they have effectively obfuscated those dependencies or those imports in order to make it harder for us to identify what functionality is being carried out by this particular application. So if we go back to, and I should mention also, so the entry point function here is DLL entry point. This is a name that's given to the DLL, or sorry, this is a name that's given to the function by IDA, but this is effectively just that entry point address. And then in Microsoft Windows, so if we look at what was analyzed by Detect Easy, we can see that this was compiled using the Microsoft Visual C++ compiler, C++ compiler, and the result of that is that it embeds what's called DLL main. So this is a particular function that was identified by IDA that is, again, particular to portable executables that are compiled using the Microsoft Visual C and C++ compiler. So hopefully that makes sense. These are just kind of weird things that get embedded into the database that a lot of people don't really acknowledge or go over, but they can be kind of confusing for beginners. So I just wanted to mention that. Okay, so one second, I'm just going to grab some water. So if we look at some of the instructions here, we can see one, there's, okay, so another attribute of IDA and pretty much every reverse engineering suite that I'm aware of is it will have local variables within the current stack. So for those of you who do not know, the stack is essentially made up of, or actually I can get a visual open for this. So I'm not just talking at an IDA database. Sorry, I guess this is slower than I thought. Okay, so this is a presentation from the course we created called Introduction to Malware Binary Triage. And so if we look at, so this is an example of the stack when a call is made to a particular function. And how the stack is set up is it essentially has the stack, the ESP, which is the stack pointer register, pointing at the base of the current stack, and the local variables for the current function and a number of other information based on call information is saved to the stack relative to ESP and relative to EBP as well. So EBP is the register for the base frame pointer, and the what you will see here is that these local variables are relative to the base pointer here, but at negative offsets. So this is probably the most confusing part for beginners when you're talking about assembly and function preambles and all this stuff. But if I open this presentation back up, the base pointer for the current frame is actually using negative offsets to these local variables. So how this frame is currently set up is the local variables of the current function are at these like -4, negative hex 10, negative hex 14, and negative hex 18 addresses. And then these are essentially used within this particular function. I don't know if there are any global variables in this particular sample. There are. So these might actually be characters, it kind of looks like. Anyways, that's okay. So these global variables are outside the scope of a certain local function, and therefore they're referenced differently within the IDA database. So again, won't go into too much detail just because we kind of want to make some progress on this malware stuff, but I just want to give you a frame of reference for how some of these things work. Hey, sexy guy. Okay. Hello, I have a question about an analysis process. When analyzing malware, is it necessary to analyze all pseudocode presented in Gijra or IDA to understand the specific actions performed by the target binary file? Or is it more efficient to focus on functions, Windows API calls, and system calls that you would deem important? Alternatively, you could prioritize analyzing notable behaviors observed by it during dynamic execution, record and analyze the different behaviors in any run or sandbox execution. So that's a great question. So more often than not, if you want to be able to fully understand how malware works or what the malware is exactly doing, you want to do what's referred to as static analysis, which is what we're doing here. Sorry, my nose is itchy. And what this does is it gives you a complete and basically undisputable vision of exactly what the malware author intended to do. Whereas performing a sandbox run, say using any run, that will give you high-level artifacts as to what the malware is doing, but it won't give you those exact instructions. So I view, if you're looking to know exactly what the malware is doing, then yeah, I would suggest doing exactly what we're doing today, looking through all the instructions and seeing how they work. But if you just want a general overview of what the malware is doing and its operations, then you can use something like AnyRun. However, there's a big caveat to that, in that a lot of these malware variants are designed to be able to evade those sandbox platforms, and therefore not all of them will run in sandbox platforms like AnyRun, and therefore that will result in you not getting the information that you want out of the particular malware sample, if that makes sense. Okay, so let's continue with this. Okay, so again, these, hopefully that made sense. Hey Cindy, how's it going? Thanks for dropping in. We're just looking at this malware sample, I was kind of explaining how the stack addresses work in IDA, how files are loaded by IDA, and then just kind of showing how IDA represents instructions loaded in memory. As they would be, it represents instructions as they would be mapped into memory by the loader. So just all the basics. Okay, so if we go back up here, again, this is highly obfuscated in that we have, so these strings are kind of interesting, like Bruce grants him his wish. I think there's a few others like this. Betsy's nephew teaches them mathematics, whatever. I think these are just random strings. I don't think they actually, I Googled some of them before, and I don't think they actually are from anything. They might just be to increase the overall entropy, to lower the entropy, I guess, by having less randomness in the binary, which is commonly looked at by malware authors, by malware analysts, and antivirus products and what have you. But we can see a string referenced here, which was referenced earlier to blindworm.cab. So if we look at the where else this is referenced in the database, we can see that. So let's just rename this to blindworm for now. And then, okay, so this is moved into EDX here, pushed onto the stack, and then it is passed to this call. So we don't know what this call is made to yet because this is another local variable. But if we look at the cross references to this, we can see that the result of this call to 1000073EC is moved into that local variable here. So if we look up here, we can see that the string create file A is moved into this 7 EC address, and then moved into EDX, and then pushed onto the stack with this global variable here with this call. So we can analyze this further, but I highly suspect that this is some form of resolution function. So if we look at this global, we don't know what that is yet. But this is some form of function resolution, and then the address of that resolution is being moved into 770 here. So let's just, for the sake of simplicity, say this is create file A. And then if we look at the call here, again, the blindworm file name is being passed to create file A. So if we look at the push instructions for this as well, we actually want to look up what create file A parameters are being passed to this function. So if we look at, let me grab the browser here. If we look at create file A in the Microsoft documentation, then we can see there's a whole bunch of different parameters that are passed. So LP file name, so that cab file name that is being passed, the desired access, the share mode, some security attributes, etc. So if we go back here, we can see that, okay, this blindworm.cab string is being passed into create file A, and then the attributes from this variable, whereas if we cross-reference those, then again, it's the result of this call. So what we probably want to do is, from a beginner's perspective, we could analyze this statically, solely. But what we can probably do to speed things up is figure out what all of the calls here are, and then mark up the database accordingly. So if we scroll back up, we could probably get away with going to the point where that file handle is created. Oh, let me pull up the chat. So if we go back down to where we just were, so you can hit, if you want to go back to a previous safe position, you can hit this back arrow. And then I'm going to hit spacebar again, so then we go back into the linear view, and then we can see this is the address of that call. Okay, so if I copy that and then paste this in x64 debug, then we're going to break on that. And we're probably going to have some of those other functions that weren't resolved earlier resolved. So we'll be able to look at those as well. So we have an access violation and it stopped. Okay, so that's not good. Basically, we didn't get to this point within the file execution, so there might be some sort of anti-analysis. So let's go back here, and then let's see. Let's scroll back up and see what else could be going on here. So typically, if I hit some sort of exception, I'll want to see where that's occurring. So I'm just going to make sure that. So as you can see, I have a whole bunch of different read-only shares because we don't want this malware to be executing anywhere else. And I should also mention this is a host-only network, so this machine cannot reach out to the internet. So even though that malware may have just executed fully, I don't think it did, because it is being controlled within this debugger. One, it can't reach out to the internet, and then two, it can't access any of the shares that we have currently mounted. So, okay, so let's go, so we're at the entry point. Let's let that exception occur again. And it looks like the access violation is happening at this 3C offset. So let's see. Okay, so we have this relative memory address that is being accessed by this local variable. So if we look back in the IDB 1000 for, I could just copy this from here actually. Then this, it looks like the issues with this var38 here. So again, a bunch of obfuscation, which makes things a little bit more difficult, but we'll get through it. So let's see. If we, I'm just going to restart this because I didn't see the exception. So the exception would be at EAX. So it looks like this address isn't even mapped. So I wonder why that is. I also didn't test this on Windows 10, so maybe it could be an issue with the sample itself. Let's, so another thing we can do is, I'm going to take a snapshot and then I'm just going to run this dynamically without the debugger attached to see if it could be a anti-debugger issue. Okay, so hold on, let me go through the chat. So Cindy said, just adding to Josh's excellent answer, you definitely don't need to fully reverse engineer every function of a binary to understand what it's doing. Distinguishing between interesting code that's part of the main logic and the malware, and not interesting code that's part of libraries or just boilerplate code written by the devs is an important skill. Yeah, so exactly, that's also a very good point. El Mato said, discover / deobfuscate the C2 list, code injections, how the malware creates persistence, how it evades AV solutions, et cetera, the interesting stuff to answer some questions. Yeah, so in that course I mentioned earlier, that's like basically the entire point. So this introduction to malware binary triage course that I was talking about basically goes through like every facet of looking for quote unquote interesting functionality and extracting indicators of compromise to look for in your environment, et cetera. Okay, so let me go back and let's, I think that snapshot, oh, I didn't create it yet, hold on. So So I'm just going to create a snapshot so we can revert later on. And usually you want to, if you're going to run something dynamically, you want to create a snapshot first. I should have done that the first time I was debugging this, but that's okay. I have like a snapshot even before that. So, okay, cool. So that's done. So then I'm just going to run the cab file. And then we're going to do what's called passive dynamic analysis. So I'm going to use an application called Procmon. And this is like very kind of malware RE 101 stuff. So Process Monitor is a sysinternals tool, and it will effectively monitor every operation that's occurring on the machine and then record it. And it has a bunch of different types of operations that can be used. So I'm just going to close our IDA window here. And as you can see, there's like a lot of noise because there's a lot of things that are occurring on an operating system at any given point in time. Yeah, Procmon MVP. And then we also have, I think there's Process Explorer on here. So Process Explorer is just like a task manager.exe on steroids. So it gives you like the process hierarchy and stuff. Okay, so what we can do here. Oh, and the other issue might be us not running the DLL within the self-extracting archive. So what I might actually do is instead of running this fully passively, I'm just going to run this with, that's actually probably the problem, is running the DLL on its own without the correct function entry point being called that we were seeing in the NSIS installer code is probably the problem. So let's see here. So instead of running the sample like I did earlier, let's rename this to .exe. And then as you can see, there's like a little installer icon now because we added the extension on, for Windows. And then since we don't know what address the DLL is going to be loaded at, we can actually do, we can use these settings to set a breakpoint on each DLL load, and then we should see it. Yeah, that's what I was just going to do. Okay, so let's see. We should see the self-extracting archive in Procmon. So see the installer is doing stuff in Procmon. But if we go back to, okay, so we just loaded system DLL, which is, so if we look at this path, if we go to temp, we can actually see where the self-extracting archive in action. So we can see in temp we have blindworm.cab, and then we have supersonics.dll. So if we go back here, and then we can see system.dll was loaded, and then system.dll is used by the NSIS installer to run that script I showed you earlier. Okay, so then we get supersonics.dll loaded now. I know I'm going fast, but basically what's happening is x64 debug is telling us every single time a DLL is loaded, and then we can see at which address that was loaded. So in the memory map view, this shows us all the current modules in memory. And then if I look at the address at which supersonics.dll was loaded, it's this 2FB quadruple 0 address. And if I go to that in follow in disassembler, then it shows us, well, this is the beginning of the module. We don't actually want that. We want the text section. Then these are those instructions for that DLL that we had loaded independently of the self-extracting archive earlier. So pretty nice. And then actually if this obfuscated code loads any additional DLLs, we'll also breakpoint on those. So it's super useful. Okay, so is this font too small, by the way? I can make it bigger. Maybe 12 is too big. On the laptop is fine. Okay. So, next thing we want to do is, so since this was loaded at a different address, so I'm just going to open this again. So since the DLL was mapped into memory at a different address by the self-extracting archive, then we want to rebase, what's called rebase. So we want to change the base address of our IDA database to match that in x64 debug. So if I go back, so I can right click in this disassembly view and get back to that memory map view by going to follow in memory map. And then I can copy this address by going to copy address and then go into IDA, edit, segments, rebase, and then I can paste that address. And then now this is mapped at the same memory address as the one in our debug session here. Hopefully that makes sense. So if we go back to the create file call that we were interested in earlier, then now it's at 2FB18A0. And I'm going to set a breakpoint for that. And then, hold on, what I'm actually going to do is just do another snapshot because I don't want to set all this up again. Luckily, I have like 4 terabytes on this machine, so it doesn't really matter. Okay, so that's done. So let's hit run. Okay, Supersonics was loaded again. And then, okay, create file was hit now. So now we can see a few different things. So these calls that weren't resolved earlier are now resolved. So we can see a bunch of different. Oh wait, so that's the actual. Hold on, go back. We actually don't want to be there. So these calls are now resolved. So if we go up, but if I double click this, shouldn't it go to the global variable location? I guess not. That's okay. If I go back to IDA, then this is probably a function table. So if I go to this address, oh, I think I can do it this way. Whatever. Let's go to it in our dump here. Yeah, so we have 3 resolved functions. We have get proc address, global alloc, and get module handle. So if I do this, and this is like the super manual way of doing this, you wouldn't usually do this, but just for the sake of the beginner stream, I'm doing it this way. But now we can mark up these addresses. So so this is get proc address. This is global alloc. And then this is get module handle A. Okay. So it looks like there's a few others that are not resolved yet, but that's okay. But now if we go into back to our code, we can see, oh, this should be resolved too, right? 2FB. Yeah, so if I go to this address in x64 debug, we can see even more functions. So we have get file size, read file. Okay. And let's see what else isn't resolved here. So another cool thing you can do in IDA is just search the text for particular instructions. So if I go to the very top here and we want to look for call locations that are currently not resolved, we can do search text and then call and then find all occurrences. And then, okay, so it looks like a few local variables aren't resolved here, but we can do that. So if we go to this local variable, and again, we might not be at the point in the execution where this is being called. This is an NTDLL function. Why didn't we get the symbol for it? Interesting. Okay, maybe that's not pointing at a valid address yet. All right, so anyways, let's continue. So what we can do now is see what create file is being used for. And as we can see in well, we can see in x64 debug. We don't really need to do it in IDA. Create file is being used to get a handle to blindworm.cab. It's getting the file size of that file. It is performing a global allocation, likely for the size of that file. It is then reading that file into memory using read file, and then it does a bunch of different operations. So this is kind of the point that we want to get to, and figure out what exactly those operations are, or simply figure out what is being done with that cab file. So I keep calling it a cab file, but if we actually look at the data for that cab file in HXD, this is actually not a valid cab file. So this is just encoded data. Okay. So just because something has a particular extension doesn't mean it's actually that on Microsoft Windows. So just so you're aware. Like if we were to open a different cab file, it would have a, yeah, it looks encrypted to me as well. Okay, so let's look at this in IDA again, or after the global alloc stage. Oops. And then it looks like to me, okay, so the next thing I wanted to go over, because this code is getting a little bit more complicated, and typically on a day-to-day basis as a malware reverse engineer, I wouldn't be solely looking at the assembly instructions. We can, but usually I will use a decompiler of some sort. So for those of you who have been watching the binary ninja streams, you would have seen this with those high-level intermediate language formats that I was talking about. But IDA also has a decompiler called hexarrays. So if I hit F5, it's going to decompile this function and give me like a pseudo C representation. And if we look at the right-hand side here, we can make these sync up. So if I have a particular set of instructions highlighted, then they will be displayed in the pseudocode representation here. So this is actually quite a bit better of a way to look at some of these instructions. So for example, like this call to read file, it has all the arguments here. And then we have our buffer here that is globally allocated. And then we have the second global allocation that's made here. And then if we scroll down here, we can actually see these other stack operations that are being made. So if I hit R to convert these, it just looks like, okay, maybe this is not ASCII data or anything like that. If we look at this word that's being referenced, we could see, okay, there's an E, but it looks like that this global value, so 69, this word is a while loop counter. So we can say this is length. Oops, it would help if I could type. And then it looks like this, or current length, is going to, while current length is less than or equal to 166, so whatever, max length, whatever we want to call it. Basically, I'm just showing you how to do markups in IDA, and then how the decompiler is super helpful. And then on each iteration, it's adding this value. So these don't look like super helpful operations, but once we get to this step, we can see a few things. So we have a while loop nested here. This doesn't look like a valid instruction, because if you look at the max length, we have 166, and then on each iteration it's adding 217. So this isn't really valid at all. It's probably just for this assignment or whatever. But if we look at these two nested for loops, we have some interesting operations that are occurring. So we have this index that's being used for an XOR operation, and that's being also passed to this for loop, and then also being used for an XOR operation. So as got a drop. Okay, take care, Cindy. So as Everest alluded to, this is likely encrypted data. So we don't have to reverse engineer all these encryption operations simply because we're mostly interested in the end result, which is the malware. So if we go down here, we can see, okay, so maybe, let's see, is this actually used anywhere? No, I think these strings are just used for nothing. So again, a bunch of encryption operations, further global allocations. Then we see get proc address being made with this module name, etc. So I'm interested in what this particular get proc address call is made. So let's look at that. Basically, what I'm doing right now is just trying to get to the stage where we have a decrypted next stage. So, and I can show you how to speed this up, but it's kind of important for us to look at each step individually. Okay, let me, so we want this address. Okay, so now it's calling get to count. And I just did notice, I think this is probably a DLL. Yeah, it's kernel 32, okay. Okay, get to count. Get cursor position. Okay, so this could be some like anti-analysis stuff. So I'm just gonna try and speed this up here by, okay. So I think it's looking for a static cursor position probably. Get to count again. Okay, so what malware will often do is it will, like, so when I mentioned earlier, there's those anti-sandbox techniques. It will often look for non-normal human operations. So if like the cursor is standing still, so that means that the cursor hasn't moved, so there's probably not a human on the system. If there are pauses between specific operations, so if it calls get tick count twice, and then the difference in time is longer than a certain comparison, then it knows that it's being debugged and stuff like that. So so this is kind of like a little bit more, sorry, I didn't mean to bring that up. This is a little bit more advanced than I thought it'd be, but that's okay. So let's see if it exits out here. Okay, so now we have a call to virtual alloc, and then we're also resolving write process memory here. So so this is performing process injection. So again, these are kind of more advanced topics, but once we get to the final payload, it'll be a little bit easier to analyze. But malware will often perform what's called process injection into a given process. And what that means is basically it will write a decrypted version or a deobfuscated version of the malware into a separate process and then execute it. The reason it does that is because it's harder to analyze and a little bit more stealthy in that you're not executing within the original process that you're executing in. So if I scroll down here, so it's probably resolving write process memory in order to write data into a separate process. So let's go down here and then some more functions that we could mark up if we wanted, but we don't really need them right now. Okay, exit process. Oh yeah, and we do want to break on any calls to write process memory. Okay, so we just hit write process memory, and as we can see, it was called from, so this bottom right view is the stack view, and if we want to see where this was actually called from, we can look at the return address here, which is this address, and then we can see it was called from here. And more often than not, you'll have data that's being, the disassembly is kind of freaking out here. So if we go to this in IDA, then this is actually write process memory. And then this is basically all of the process injection code. that's happening right here. So instead of me analyzing all of this in detail, we can probably get to a point where that next stage is decrypted in memory prior to it being mapped. So let me go back up here. We should have that original worm functionality that I looked at, or that cab file decryption. Yeah, this stuff. So I actually want to see where this was written to, because there's probably a decrypted loader here. How's everybody doing? Oh. Hey, Anthony Rice Code. How's it going? Thank you so much for the raid. Yeah, I've never gotten a raid before, so that's super awesome. And it's a huge party, so thank you so much, Anthony Rice Code. Yeah, that's so cool. How y'all doing? Yeah, it's going well. We're reverse engineering. We're doing a basic malware or introduction to malware reverse engineering stream. Hey, Jawsons, yeah. So hold on, I'm going to pull up Anthony Wright's code and make sure to give Anthony Wright's code a follow here. Software and game development, awesome. That's super cool. So yeah, everybody make sure to give Anthony Wright's code a follow, and thank you so much for the raid. How did the game development go today? All right, let's keep going. So, so yeah, just to give everybody or get everybody up to speed, we're basically looking at a piece of malware that was extracted by this self-extracting archive that we identified as, this is the wrong file, let me show you, as a nullsoft scriptable installer. Just a quick stream where I was fixing my Nintendo Switch microcontroller timing by adjusting how I interacted with HID. Wow, that's so cool. That's very, that's hardcore. So are you actually, so do you have like an actual debug interface into your Nintendo Switch? That's really nice. I've never really done a ton of like game console hacking, but I always wanted to. Like that Bunny book on hacking the Xbox is super good. All right, so let's look at this allocated buffer here. I have an Arduino that pretends to be a wired pro controller, and I have some very interesting time and behavior. Cool. Nice, that's awesome. All right, sorry, let's get back to what we were doing here. Okay, so this looks like the strings for this loader. And okay, so what I might do instead of stepping through all this decryption code one by one is, for the course, I actually have a x64 debug script that we can use to basically do everything we're doing by manually stepping through this, but automatically. So I'm going to get rid of all these breakpoints. And then Jawsons, I'm a game dev, but due to some offers, I'm now learning embedded to mostly ARM assembly and now also RISC-V. Nice, that's awesome. That's very cool. I need to get better at ARM assembly because a lot of new malware is coming out for Mac OS, which is moving towards assembly. So, and there's a bunch of embedded stuff that's targeted by malware that's also ARM. So, okay, so what I'm going to do here is load a script, and I'm just going to show you what this looks like. This is available on GitHub, and I'll link this. But if we go to lab 15, basically what this script does is it just sets a bunch of breakpoints on APIs that are commonly used for unpacking. So as you can see, it has like create remote threads, set thread context, read process memory, write process memory, etc. So what I'm going to do is actually restart this. And then I'm going to disable that DLL load feature. And then before this executes, I'm going to go to that script and hit spacebar to enable all these breakpoints. Okay, so it just says unpacking, injection, and file operation API breakpoint set. And then I'm going to hit run. And then the ZW create section is pretty legitimate. It's not usually called directly by malware very often. So I might remove that one actually. I'm going to disable it. Let's let it keep going. And again, this is going to take a sec because it needs to decompress the archive, load that system DLL, etc. Okay, so it looks like write file is being called here. And okay, no, this is just the self-extracting archive again. That's going to write all those files, but obviously this is good to know. Okay, NT-unmap view section. Okay, so we have a decrypted portable executable in memory. So what just happened was, let's see here. Let me just make sure this is indeed what I'm talking about. It's in the thread stack. Okay, whatever. I think this is because it was probably allocated using heap alloc. So it just looks kind of weird. Okay, so I'm going to dump this memory and I'll go over what just happened in a second here, but let's see if this opens. Okay, so let's open this. Okay, so now we got what's probably another stage here. So if we look at the strings, also looks kind of obfuscated, whatever. And if I let this keep running. So, okay, so let me just back up a little bit. So this script will automatically, I'll just pull it up on GitHub. And so this is the script that I just used. And basically all it does, again, is it just sets a bunch of breakpoints on common APIs that are used by malware during the unpacking process. And then I just hit, we just hit a very common function that's used by malware called NT-unmap view of section. And that call was made from a second portable executable, I believe. So, but it was called by, let's see, let's back up here. Let's see what function was actually called here. So basically I'm just walking back up the stack in the debugger until we get to the location that it was called from. Oh, so that was just get module handle. Load library X. Okay, so this might be, yeah, this might be irrelevant stuff. So let me, we basically just want to get to that point where we were before. So I'm just going to do that. Okay, virtual protect. Okay, now this is where we want to be. Okay, so it's creating a process. It looks like that process is just another copy of itself. So yeah, what malware will often do is it will basically execute another copy of itself and then will inject into that copy of it. So we'll let that happen. So if we look at the process explorer here, it will also create that process within a suspended state. So if I do run here, then we can see under our first installer process, we have a suspended process. Okay. And this, I think this is a suspended process from our first attempt that we kind of ditched there. So we could probably just kill this. Okay. So So this second copy of that executable is what's going to be injected into by this process. Okay, so now we're going to do a virtual alloc, which we always want to look at. And then let's make this view more of a hex view. And then typically we want to set a breakpoint on any memory allocations that are being performed by the unpacker. So I'm just going to do that. And then we can see those decryption operations are going to be occurring, right? So let's continue. So it looks like some data was written there. And then we just broke on read process memory. So this is going to be reading information from the process that's going to be injected into. Okay. And then we hit NT unmap view of section, which is going to be basically unmapping the current process in memory. And then we have another called a virtual alloc X. So if we look at that, then this should be, this is the base address of our, this is the base address of the original executable. Yeah, it's kind of like a free. So on Microsoft Windows, there's like a bunch of APIs that are used by the Windows loader. So in this instance, the malware is basically taking parts of the process that it's injecting itself into out of memory using these unmapping functions. This is all kind of very specific to Windows. So if you're mostly doing embedded stuff, maybe this is like foreign to you, but this is all like very common stuff for malware to do. Okay, then now we have write process memory. So if we want to look at write process memory here, let's pull up the docs for that. Then we can see there's a handle to a process that's being written into the base address and then the buffer. So if we go back here to our virtual machine, then we can see that this would be the handle to the process, the base address, and then the buffer, and then the data that's being written into that process. So let's take a look at what that looks like. Okay, so this is a portable executable. So let's dump this. So what usually happens is a piece of malware will overwrite a remote process with its own executable after unmapping it, which is kind of that free stuff that I was talking about. Okay, so what it's being overwritten with is this data. So I don't know why it's not letting me go there. One sec. Okay, so let's dump this. So I'm going to go to follow in memory map and then dump memory to file. Let's save that. Okay, so now I'm going to open that in IDA, and that should be our next stage. So this can happen without causing any protection faults from the kernel. Yeah, so what will often happen is so the process that's being injected into is in a suspended state. So it's not currently executing. So that's one factor. The unmapping will basically also ensure that no issues occur during this injection process. And then they will actually also change the memory page permissions within the target process that's being injected into in order to make sure that there's no memory errors when they write into that as well. So hopefully that makes sense. Basically, they prep the remote process to be injected into. Okay, so then, cool. I'm glad that made sense. 4C, process hollowing, does something similar. Yeah, so I don't know if this is actually using strictly process hollowing, so that's why I keep calling it process injection. But yeah, that's effectively what this is doing. Oh yeah, so we don't have, hold on. So I dumped the entire memory page. Oh yeah, all good, El Matos. So we actually need the offset at which the, okay, so I need a calculator because I need to calculate the, or I guess we can just use Python. Hold on. So if I have the, so I'll tell you what I'm doing in just a sec, but cool. Awesome. That's great to hear. So hold on. Minus 4C copy. Okay. So basically I need the offset at which the portable executable starts within this memory page, or this memory allocation rather. So I was kind of like mumbling to myself earlier that this looked kind of weird, because when you have a memory allocation that's made using virtual alloc, it's made at a page boundary. Whereas in this instance, because it's a heap allocation, it's done within a seemingly like not random, but a non like rounded address. And I just dumped this entire memory page. So you can do that by going follow in memory and then right clicking on the entry and then going to dump memory to file. And then basically that dumps the entire memory, which I did. And then if I open that in a hex editor, I'm just gonna close these out because we don't need them anymore. Yeah, I don't think rounded is the correct term, but basically starting at like like an even address, like see how it's like 02FB quadruple 0. I think a page boundary is the correct term. But like, I don't know. Basically, I just meant the file that we want, that we extracted from memory, is like in the middle of the memory allocation here. Okay, so let me go back to the hex editor, and then this is our file here, and we actually want to go to. Okay, so I'm actually gonna do this using Python because I don't. Maybe I can do it. Okay, so another term for page bounds. Yeah, exactly. Forward text strings, case sensitive. Okay, so this is where that I didn't even really need to calculate the offset. Oh, but this is gonna take forever. Maybe I will use Python. Okay, so let me get I just like doing things faster. So Python 3. What? There's definitely Python on the system, so I don't know why it's just Python. Yeah, okay. Open, or let's do open our file, and then I'm going to read all the binary, I'm going to open it with RB, so it's in binary mode, and then I'm going to read all that data into, I won't do all this in one line because, so our file contains that, all that memory that we just dumped, and then this is what that memory looks like, right? But we want to get to that portable executable file, which is what I was calculating with that calculator. So if I, oh, did I erase it? No, that's okay. Copy address. Oh wait, no, I didn't do it. Ugh. Sorry, my brain is like very tired today. But we can do it in here. So I can do. Okay. Oh no, wait, that's gonna be the memory address, so that's not gonna work. Hold on. I need the physical offset. All right, so let's do copy address. So offset is equal to. All right, and then we'll go to. Again, there's ways to automate this, but I kind of want to show you the manual way because that's how you learn properly. Our file, okay. Right, so double click on the address and the dump, it will show the address relative to the offset you clicked at. Oh yeah, you're right. Sorry, Duncan. Noob, I'm a noob. Okay, so I'll show you what Duncan's talking about. So I can do that, right? Is that what you're talking about? Oh, let me open up this image. Yeah. Oh, but started at the beginning. Sweet. That's awesome. Okay, so 5AEF0. That's the way better approach. Yeah. Cool. So now the offset is 5AEF0. Then we have our R file offset. And then we don't know how big it is, but I just want to make sure this is correct before I dump it. Okay, so 45A, so that's the beginning of the portable executable header. Okay, and then dumped or unmapped MZ. And then we'll do FW open carved PE.bin write, and then FW.write unmapped MZ. Did I not do? Oh, sorry, I didn't open it in binary format. Okay. So all I did was I went to the offset. So I went to this offset using Python and then just deleted all of this data before it, so we have a valid portable executable. So it's actually kind of annoying to get the correct file, so I'm going to use this plugin called Sila to rebuild it. Okay, I'll just dump a random file and then what do you mean? Maybe it's PE rebuild. I can't remember off the top of my head. Okay, so yeah, we basically I just got Sila to resize this, because after this portable executable, there's also a bunch of stuff in memory because this is all heap allocations. So I think anyways, this is all like, these are kind of assumptions, but okay, we can close this. And then let's look at what portable executable this was, or what it is. And then there's linked debug information of this. So they probably overwrote their PDB path that's embedded by Windows. What is a portable executable? Oh, what's a portable executable in RE or malware? Okay. Yeah, so it's just the executable format on Microsoft Windows. So if you've been working on game stuff or like embedded stuff, then it's like the ELF file format, but for Windows. If that makes sense. Okay, so let's see. This looks pretty good. We might have our final malware binary here. Yeah, I think we do. Okay, cool. So I'm just going to run to the washroom because I really need to go to the washroom because I drank much water. But so what I'm going to do is so the way I afford my IDA license and a bunch of tools and stuff that I use on this stream is through a course that can teach you how to do all of this stuff step by step called Introduction to Malware Binary Triage. There's students that are probably on this stream right now. The community is getting pretty cool, so it's been really nice hanging out with them on Discord and stuff. But basically, this is how I can afford all these cool tools and stuff like that is by running this course. So I'm just going to run like a quick ad for it, and then I'm going to be right back. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, I'm back. All right, so let's look at this actual malware. After all of that unpacking took me like way longer than I thought, just because I thought that first, like I just quickly looked at this last night, but I didn't want to look at it too in depth, just because I want to do it mostly live on stream. The generic unpacking method that I used is a little bit better than looking through unpacking code, just because it can be like heavily obfuscated and stuff like that. But it's still good to look at how the unpacker functions to some extent, right? So we could reverse this entire thing, but again, not really necessary in this instance since we just want the final malware. So once you have a fully unpacked malware PE, the first thing you kind of want to do is look at the strings. Again, these could be obfuscated in some way, shape, or form. But if we go to view, open subviews, strings, then we can see a whole bunch of interesting stuff. So the first stuff is, this encoded data looks interesting. We have a Mozilla 5.0 user agent. We have a zone identifier. So these are commonly used by files that are downloaded from Internet Explorer to know that the file was downloaded from the internet, I believe, unless I'm thinking about something else, but I'm pretty sure that's what that's for. autorun.inf. So this is commonly used. I believe that was used for like USB propagation by writing those to USBs, but that doesn't work on Windows anymore. But this piece of malware is kind of old. Oh yeah, and by the way, I can kill this now. So I'm just going to hit close. And then I'm going to kill this process. Okay, so let's take a look here. So again, the strings just give you kind of a high-level overview as to what the malware could be doing. Oh, look, so we have an IP address. We have all of these interesting .ru domains, .su domains, etc. Oh yeah, so like a whole bunch of different malware-looking domain names. But yeah, this just gives you like a really general overview as to what interesting functionality could be in the binary. You can embed any type of string you wanted, so it doesn't necessarily mean it's going to be used by the malware, but it's still good to look at. We have current version run paths, so this is probably used for persistence by creating a run key. We have a whole bunch of different API strings, and then we have a whole bunch of different interesting APIs. Part of one job offer description was designing and writing secure programs for mobile and some low power devices. So I'm only learning RE and malware analysis on a theory level for now, but I guess this stream is still very relevant to me. Yeah, like, so I highly suggest checking out Lori Wired. So Lori does very similar streams to this, but for mobile security. Oh, she might be live right now, actually. So yeah, let's see. So yeah, definitely check out Lori. Lori also has a YouTube channel that's is probably really good for what you're looking at, which I'll also link here. But yeah, Lori's probably the best, or like the best kind of up and coming analyst in the malware space, or in the mobile malware space right now. And she also talks about like risk and like basically everything you were just talking about. So definitely super relevant. Okay, so let's continue looking at this. So okay, and then as I mentioned earlier, probably the next thing we want to do is look at the imports. And we have a bunch of interesting imports that we saw in the strings tab as well. So we have registry creation and set APIs. We have, again, unmapped view of file. So that could be related to process injection. Set current directory, get full file path, get module file name, get logical drives, etc. Create tool, help 32 snapshot. So this is, and then we have these process enumeration functions. So create tool, help 32 snapshot will basically create a snapshot of the current processes running in memory. And then these process 32 functions can be used to walk that process snapshot that's been taken. Cool. Yeah, thanks, Jocelyn. I appreciate it. That's a nice compliment. Okay, so, and then we have get locale information. So that could be related to like language identification if they're looking to not infect particular computers, or they're just looking to send that back to their command and control server. sh get folder path is used to get certain types of folders. For example, like temp has a particular identifier. Anyways, I could just go over on and on and on about what these could be used for, but let's actually see what they're used for. So if we go to, again, IDA has put us into this start function, which is the entry point of the program here. And if I bring up the pseudocode for this, again, we can work through this a little bit faster than just reading the assembly. And then we have a call to win main here. So this is actually the one we're interested in. So first we have a while loop, or we have this 9090 integer, which it looks like this is used within this while loop. And then we have a sleep that's also made for 1000 milliseconds, which I believe is just 1 second. And then we have copy file A, which is copying this seemingly 0-byte value into the existing file name. So I should probably figure out what this is. Okay, so it's just itself. So win main takes arguments, and this is just the file name of executing malware. And then we'll just call this. And then it's moving. I don't really know what the point of this is. Anyways, let's keep looking at what else there is, because it doesn't seem super relevant. Okay, so then we have a if statement that's made for this call function, and if it's not present, then it exits. So we probably want to look at what this is doing, and it looks like there's some interesting self-deletion functionality here, so we also want to look at that. So let's look at this 401 function. Okay, so here we have some additional anti-analysis techniques. So is that a C2 list? Oh, it could be. That's a good point. Yeah, maybe there's copying, but why would they be using copy file? Maybe they're, do you know what I mean? Like, why would they be in copy file on it though? Yeah, I think these are C2s for sure. And there's an IP. I just don't know what this stuff is, but we can probably debug it to for me to figure out exactly what's going on. I know find window a. Hold on, I promise this won't be a long distraction. Okay, so we have the class name and then the window name, and it's just getting a handle to the window. So the class name is 0. Yeah, so I don't know, not super relevant, but let's look at this because this is definitely relevant. So on Microsoft Windows, there are techniques that can be used to discover whether or not you're within a virtual machine. So this is why we kind of want to, based on like the questions that were asked earlier by that other viewer, the problem with using virtual machines and sandboxes is they can be detected by malware. So in this instance, we have this QEMU string, we have this virtual string, VMware string, and a Zen string. So let's just call these virtual machine strings. Oh, cool. So it could be an anti-debugging technique. Nice. Thanks. Easy to handle to the top level. Whose class? Specified strings. This function. Okay, cool. Nice. Thank you, Almados. So these virtual machine strings are then compared to against this data. So if we look at this out buffer for device IO control, we can look at what this constant is for device IO control to see what's being enumerated. So apparently it's ioctl storage query property. I'm just going to see exactly what that is because I don't know what that is. So the control code, we should have a list of control codes. Maybe I'll just Google the actual control code. Okay, so I should probably explain what I just did. So the okay, so in IDA, and a reason IDA is really nice to use is because it has the constants that are used in Microsoft Windows built into it. So all I did there was I hit, so you can highlight a constant and then hit the M key as in mother. And then it'll try and look for constants that map to those values. So in this instance, when I hit M, it brought up the ioctl storage query property constant. So that's how I just found that. And that's really useful because we can then figure out what's being passed to this device IO control function. And basically device IO control is just used to query information about the system. So Windows applications can use this control to return properties of a storage device or adapter. So essentially what it's doing here is it's querying the storage devices into this out buffer, and then it is checking for these virtual machine strings. So this is calling a string and string. So it's basically looking for that substring in the storage device of the operating system. Does that make sense? So, and with a lot of these sandboxes, it's actually hard to, oh, and I forgot to go over this create file. So it looks like it's just getting a handle to the physical drive 0, which would be the first hard drive that is stored within the computer. And then it is getting a handle to that device, and then it is also passing that to device IO control. Okay. So if we go up here, then I'm going to rename this to check or just anti-VM storage check. And I usually add these MW characters before each function that I'm reversing that's related to the malware, just so I can know that it's related to the malware and not some other type of functionality. So a lot of malware will statically link legitimate libraries, and then they'll end up in the final binary. So we want to mark what's actually malware and what is the actual malicious functionality. So if we go back here, so basically if the anti-VM check returns true, then we have this function that's called. So this is a very common technique as well. Sorry, just drinking some coffee. Where we have this get tick count is just seeding this pseudo random number generator, and then that pseudo random number generator is being used to let's see, is it even being used? Oh yeah, it's being used to create the file name for a script that is written to disk. So the get temp path is called here. So if we look at, this should be just get temp path, take a constant. I can't remember. Oh no, it's just the buffer length. So yeah, this gets temp. And then it's using rand. So generate in order to get a pseudo random file name. So if we look at values. Basically, it's just creating so it's using modulus on rand and then adding a to it. So basically this just gets a relative character offset to the alphabet character a, and then essentially all this is doing is generating a random file name. So it creates, okay, so, and it does this a lot actually. So it's good that we reverse that function. Or maybe we'll just say mw gen rand string, because we don't actually know if that's always going to be a file name, right? And then this length that's passed in is the length of 10. So if we look at that, then we'll name this string length. And then this is the file name. Okay. Then that's concatenated to the temporary path with the fopen, with the result being passed to fopen, which opens it. And then we have the attribute set to 80, which is probably like executable or something. Set file attributes A, let's look at that. Okay, so the attributes are file underscore. So let's do that. File read attributes, probably. Whatever, doesn't really matter. And then, so what this is doing is it creates a shell script that basically references. So if you call get file name, or sorry, get module file name with the first argument being 0, this will actually get the file name of the executing process. So it gets the file name of itself, and then it makes that file readable by setting these file read attributes. And then it creates this deletion script. So this is a batch script, and then it calls shell execute to execute that script. So basically what this is doing is it's creating a shell script on the fly with a pseudo randomly generated file name that will delete itself. So this is pretty cool because it's like an anti-forensics technique, because if the file doesn't reside on disk after it's detected it's in a sandbox, then it's hard to recover. Okay, so we'll just say mw self-delete with that. Okay. Then we have delete file with find window and move file. So a bunch of those operations with 0 bytes. Again, might be anti-debugging, but we don't care because we're not doing debugging, which is the best part about static analysis that we're doing. And then we have create mutex. So for those of you who are not familiar with Microsoft Windows, you will often have malware creating a mutual exclusion to make sure that it is not currently already running in memory. So say you have a user that downloads this installer and they're like, it's not working, and they just keep clicking on that installer. The malware author wants to make sure that there's not multiple versions of the same malware running on the computer. So then it'll create this mutual exclusion, B4, and then if it detects that mutual exclusion was created or was already taken, basically it's a technique to look if the mutual exclusion is already taken, then it checks the error. So if I do this, error already exists, then it'll exit. So it's a very common technique for malware. And actually, if these mutual exclusions are static, like this one, you can actually hunt for mutual exclusions that are currently in memory. Sounds good, Duncan. Enjoy your walk. So if, sorry, I got sidetracked. So you can hunt for processes that have these mutual exclusions opened. So antivirus will very often do this. It'll check for like static mutual exclusions like this. And then if those are created, then it knows that this malware variant is being executed on the machine. Okay, then we have that anti-analysis trick again. Okay, so this is the thing that I need to double check. So again, this is the self file name. And I think this zone identifier thing is being, it's mark of the web is what it's referred to, but I'm just going to double check that. Yeah, cool. So I was right. So the zone identifier stores whether the file was downloaded from the internet. So usually malware will want to, okay, so this is what's called an alternate data stream, or ADS. This is all Microsoft Windows operating system stuff that we don't really need to get into. But what is interesting is this ADS, alternate data stream, is used by web browsers to indicate to the user that this file was downloaded from the internet. And if it was downloaded from the internet, then a warning will be presented to the user that, hey, this file is being executed and it was downloaded from the internet. Do you actually want to run it? So obviously the malware doesn't want that pop-up to show to the malware or to the infected user. So therefore it will often see if there is a zone identifier alternate data stream, and then it'll delete it. So that's basically what it's doing here. So okay. So then we have some environment variables here. So we have window, we have user profile. Okay, so this is just an array, whatever. We don't really have to mark all these up, just as long as we know. So we have these directories that are being expanded, and then a path name that's being created. And then it checks if that path exists, and if it doesn't exist, then it creates the path. And then it's copying itself into that path. So again, this is a very good indicator of compromise, to know that if this path exists on your system, then you're probably infected with this malware. Yeah, it helps a lot with incident response, exactly. Okay, so then if that directory exists, then this enabled attribute is created. So what is this? Okay, so it is creating a format string with this string being eventually created. %s star enabled %s PSD path. Okay, so it's basically creating, yeah, so it's enabled. What is, okay, maybe if we look at the registry keys that are being created here, then it'll make more sense. PSD path. Okay, what is the value name? Okay, Windows, Microsoft Windows Manager. Okay, my guess is this is probably, let's see, HKey local machine. These are just the SAM desired, which is fine. Let's just call this enabled string. And then, okay, so this is the run path. Okay, so it looks like this is just creating the run key with the sub key of, yeah, okay, cool. So basically it's ensuring the enabled value, I believe. Do run keys have the enabled value? But basically it's creating a run key with the name Microsoft Windows Manager. And this string is also being used. Okay, sorry, I missed this part too. So, so it's copying the, so let's just say copies to file path with file name. So yeah, the awesome thing about IDA2 is you can add these comments to the pseudocode, and you can also add it to the disassembly. Yeah, this is for persistence. El Matos. And then, yeah, so basically it copies to this path with winmanager.exe, and then it uses that to create a run key with the name. Oh, it looks like it's also doing firewall stuff. So we need to, oh, I see. Okay, so this is probably firewall stuff. Cool. Yeah, so so basically the first thing it does is it adds the application to the firewall allowed list. So it basically allows the malware is making sure that it can connect to the internet. So add self to Okay. Because I can show those strings. Whatever. I want those strings to be shown inline, but that's okay. So yeah, it's adding itself to the allowed firewall list with this. Maybe I'll put this up here so it's easier to read. And then makes more sense. Yeah. I think it's actually going to add itself to the exclusion zone as well for Defender. I think I saw a string for that earlier, but we'll see. Okay, and then it creates the run key path. Okay, and then it creates it for, see the Defender string here. But, so it adds it for HKey local machine and HKey current user. And then, it's just creating it. I think it's just using the name WinDefender start. These maldev guys also follow a recipe for initial. Yeah, that's not surprising. So is this an actual Windows Defender service, or is it just creating persistence using that name? I suspect it's just creating a service for itself. Or is it modifying Windows Defender? I think it's actually modifying the Windows Defender registry key. Let's see. Let's do some Googling. Yeah. So if I bet this is going to say if you set that value to 4, which is what it's doing. Was it 4? Yeah. Yeah, so this is disabling Windows Defender start. Okay. And then I don't know what device config manager is. I don't know. There's a spoiler in here, and I don't want you to see it. So, but it's going to help us figure out what malware variant this is. Okay, then it just creates a copy of itself, I believe. But basically, if this file name exists, pathfind file name device, then it deletes itself. So I think this is another check if already running with path. Yeah, I think this is pretty old malware, so like a lot of it won't just like defend or like stop Defender from working altogether because it's pretty noisy. Like with an EDR, you would see the registry operations occur and it would probably kill it. So, okay, so what next? Okay, and a seam alert for sure. All right, so then we have the exit process. So basically what this is doing is it sets up all the persistent stuff, it copies itself, removes the zone identifier, alternate data stream, and then it starts its new process kind of within its new state, and then exits after sleeping for for 100 milliseconds or whatever. Okay, so how's everybody doing? Is there any questions? It's all pretty straightforward so far. So, okay, so this is doing create thread. And then, let's see. Ooh, cool. Clipboard stuff. This could be command and control stuff. Yeah, it looks like it. You explained very well all the aspects. I'm learning a lot. Yeah, no problem. Thank you for joining the stream. Okay, so basically it's creating a bunch of threads to do different malicious functionality now. So if we look at what this first thread is doing, we can see a few things. So again, we get its own file name. It opens that file. It seeks to a particular offset. Okay, I'm just gonna move this over a little bit so I have more space. Hey, Woosa, how's it going? And then ftell is probably going to a particular offset. Well, I just want to make sure these are all non-Windows APIs. So returns the current position of the this function returns the current value of the position indicator. Maybe position indicator of the file stream. Okay, fseek. Sorry, again, I don't know. Offset, okay. So it seeks to offset 0. Then get offset from stream, I guess. Not get, but offset from stream. Okay, and then we get, I wonder if this is actually used anywhere, if it's just more stuff that's not used. So we get all the logical drives. So if I pull up the docs for that now, it returns a bit mask representing the current available disk drives. But what's the, oh, strings A, sorry, I went to the wrong function. Okay, that's just a buffer length. Oops. Where's my virtual machine? Okay, so it gets all the drive, so basically it'll just get the like C, D, whatever for the drive names. Then it checks if okay, so I'm pretty sure what this is doing is it's enumerating for USB drives to propagate to as like a worm. So if we go to, so I think this is probably drive, yeah, drive removable. So it's seeing if the drive is removable. It's checking if it's a valid drive letter. It's getting the volume information. What is that? Third argument. Okay. Root path, volume. Okay, so this is getting the volume information. Okay, cool, yeah. So, so this doesn't work anymore on Windows, fortunately, because this is how like malware ended up on the International Space Station. Like I'm not even joking, that actually happened. But basically when you would plug, so for example, if your system was infected with this malware, it would have that thread running, which is always looking for removable drives. And if a removable drive is detected, then then this has the ability to write a bunch of files to it. So if a user would plug that drive into, say, another Windows XP machine, I can't remember if it stopped working on Windows 7, but it definitely worked on Windows Vista and XP, then it would automatically execute this VB script and then this device config manager script, or executable, which is the malware that it copies to the USB. So basically this creates a USB worm. Oh, that's a good question, Wusa. So I'm actually pretty new to Twitch. Yeah, that's a very good point. I should probably make this the science and tech category instead of just chatting. So thanks for that. I appreciate it. I will do that next stream. This is only my 4th stream ever, believe it or not. So anyways, let's go back to this. So let's mark up what these are. Yeah, it's an auto run thing, exactly. So, and then they also do stuff like these LNKs, which I'll show you how that works. Cool, and here, see, there's more of the random string file generation stuff. So if we have, LNK pattern, or we have the, it's not even a pattern, it's the file name, and then it's using the first argument as the buffer, and then it's making an LNK name using the second argument. So we got to see what's passed to this function because I don't think I checked. Thanks, Wusa. Yeah, Twitch is cool. All right, then INF. And then this is going to be the device. Ah, okay. So, so that file name check that was done earlier, this one. So this is the USB worm file name. So basically it was looking if the system was already infected with the USB worm. Getting tick count. Hold on. Where's the... Oh, this one? I don't know why it's used here. Oh yeah, so it's being used for this MWGen random string function. 81. Yeah, I got it. Yeah, so it's being used to generate random file names, I think. So we'll figure it out in a sec, but I think that's what it's being used for. Okay, so then we have the auto run INF path. We have I don't know what this underscore is used for. Oh, it's a directory. For malware. Yeah, no problem. Okay. So basically it checks if the INF, if this autorun.inf exists on the USB already. So like back in the day, you used to have like USB driver software that would be on a given USB when you plugged it in. So then it would probably have an INF that would autorun. So this is actually deleting that if it already exists. And then otherwise let's see, I don't know what these destinations are used for. Okay, this is auto generating an INF file. So we don't really need to reverse all this because basically if we look at what, I'll explain to you exactly what it's doing. But the INF basically has, so I'll Google one to show you what it looks like. There's probably one on attack. Dude, this blog's really old. Is this it? No. Does it have an example one? No, lame. Hold on. We can just use it. We can look at a legitimate one. I hope it gives us an example. Yeah, okay, cool. So basically these autorun.inf files just have like instructions on what to execute when they are when the removable media is inserted to the computer, whether that be a USB or CD drive. People don't really use CD drives anymore, but you know, some people do. So it's just basically creating pseudo-random values on the fly for these values, and then creating the script. And then it's using, so wscript here is, oh, I see, never mind. No, sorry, I'm wrong. This is actually creating this device config manager.vbs file. So what gave that away is these dims. So this is, I don't know if any of you have written Visual Basic script, but these are used to declare variables. And then this wscript create object is creating a shell object. It also creates a scripting file system object and a shell application object. So this is all Microsoft Windows ActiveX controls. So if you're not super familiar with Microsoft Windows, basically ActiveX is a part of this larger ecosystem that allows you to perform, that allows you to interface with the operating system using these scripting languages. Yeah, I would say VBS is like an older version of PowerShell. A lot of people use VBS and stuff like that before PowerShell existed. And then I don't know what send keys is, but that's kind of cool. But all this is doing is it's using this Visual Basic script on the USB to, yeah, it's also very much very popular with malicious documents. When the so how this is setting up is, and I can visualize this if y'all are interested. Let's do that actually. So how this is working is it has. So hold on, I'm just going to create a few of these real quick. Let's make the fill of nothing. Okay. So how this works is, can I put text in there? Or do I have to make a separate text box? Okay, let's just make a separate text box. Hold on, sorry. Okay, so we have USB inserted. Right? Then we have malware creates vbs.vbs and .autorun.inf. Okay. Then we can make these smaller. Then we have a INF or VBS, malware, and autorun. I don't know why it keeps auto-correcting that. It's really annoying. Stop it. Copy to USB. Oh wait, and there's also an LNK. Okay. And then, see, I'll type in back and forth. I'll be with you in 2 secs. Right, and then so I believe what's happening is we have autorun.inf calls VBS, which calls malware, or which executes malware, and then I believe, I have to confirm right now, but I believe, or another option is if this is a newer operating system, then I think they're creating a LNK that will execute the same infection chain on the USB. Right? So let's see. For sure, I remember VBS simulate and press enter key and a script to remove trend micro from a number of desktops. Autorun was used in Stuxnet as well. Yeah, I think Stuxnet actually had 0 days. So it wasn't using like this autorun.inf method, but it had like actual 0 days for Windows. So it didn't even need the autorun stuff. But yeah, still cool. Okay. Right. So this is what I thought was happening earlier, but it wasn't. But the autorun.inf file is being created on the fly, and then that executes the device config manager. It says auto plata1. This is all just autorun.inf format stuff, and then it copies it. So what I know is, okay, so this is COM stuff, or component object model stuff. But what I believe this is probably doing, okay, so let me create, I think I had a script to do this, but I think I can, oh, it's already set to an R CLS ID, right? I already did what I was gonna do, but I need the string. Okay, so Windows has like this entire other ecosystem called the component object model, or COM. And it's quite complicated, but it is often used by malware because it is very powerful. So what this malware is doing, and we could recover all the COM interfaces and stuff like that, but just for the sake of time, because we're already 3 hours in. And I want to show you all the other functionality this thing has. Basically, it's creating a link file. So for example, like one of these, it's creating one of these link files that when clicked will execute the infection chain as well. And that's using what's called a component object model or COM interface. And the COM interface is created using what's called a CLS ID, which in this instance is this 2140. Here, let's see if I can just find some example code to show you what this looks like. C. Sorry. This is probably a very long-winded approach, but basically it's doing this. It's creating a shell link file or a shell link interface, and then it creates the LNK using these CSID interfaces for COM. So that's all to say that that's what this code is doing. So I'm just going to say like MW create. Okay. Apparently this is called in multiple places, which is, oh, okay. So it's just, and then this is dependent on an argument. So create, okay. So, oh, cool. So I think it, malware string and string. Yeah, cool. So this is also a very common technique in these LNK self-propagation things. But basically what this is doing is it will find a LNK or VBS file or BAT file or JavaScript file or SCR file or like any of these file extensions on the USB, and then it will basically replace itself with the, it'll create an LNK with the same file name as one of these executable files that the user would interact with. And then so when they go to click on the usual executable file that would be on the USB, it's actually an LNK pointing to the malware. And then it will still open that same USB file, the original USB file. So it's quite clever. And again, that's only used in the instances where there's no auto INF functionality. So if it's like a newer Microsoft Windows system. So this technique is still used and it still works by replacing these files on the USB with those extensions. I can understand everything that you said. What I don't know is how you can run something that wait for a USB device to connect and then rest. So USA, basically the malware is constantly running in the background and it's constantly looking for drives that are connected that are the type of like removable drives, if that makes sense. Hold on. I can understand everything you said. Okay. Yeah, okay. Hopefully that makes sense. Basically, this self-propagation thread is constantly running in the background. So I'm just going to call this malware USB worm propagation. Okay. And it looks like it's also looking for, oh, cool. Yeah. So it also looks for network drives as well. So it'll enumerate all the network drives and then it will copy those LNKs to those network drives in order to get users on other computers to click the LNKs and then execute the malware. Okay. Okay. So USB self-propagation. Okay. So it looks like the LNK stuff is only used when it's a network drive and not when it's a removable drive. Okay. Because this Boolean, this 0 that's being passed is for whether or not the LNK stuff should be done. Let me double check that. A shell DLL. Okay, so no, it's done no matter what. What's this 8 and 9? What argument is that? 5. Okay, so this just affects the COM interface stuff. All right, we won't worry about that for now. But maybe you guys can take a look at exactly what this argument, this create LNK argument, is being used for, if you're interested, using the COM interface. Okay, so let's go back here. See, and then USA, this is done in a while loop, so it never exits, and then every iteration it sleeps for 1 second. So if anybody inserts a USB during this loop, then it'll infect the USB drive. Okay, so how's everybody doing? I might take a bite of this Cliff Bar because I'm pretty hungry. Do you have any questions? Okay. I'll answer you in 2 seconds. I'm just gonna finish eating this. So that, like, all that injection stuff, I think that was before you all joined. Or like we got basically to the point where we dumped this binary when you joined. But essentially, I think the scenario for this malware, I think it was usually delivered through email. So basically, or like it's a fake installer, so it could be basically acting like a regular software installer, but it infects their system with this malware. So the scenario in which the system would get infected is like dependent on how the malware author is delivering it. And then once the system is infected and like all that whole injection technique happens and whatever, then the USB propagation functionality is executed, if that makes sense. So I don't know exactly how this malware is delivered or how it was delivered in the past. But basically, that's like all of those first steps would have to happen before it could infect USBs. Okay, let's keep going. So it's also looking for, yeah, exactly, WUSA. Okay, so this is looking for normal drives. Wait, so let me back up. So this is another thread that's being executed. So if we look at what this is doing. Okay, so this is setting the current directory to the root file path of each drive. And then what does it do? Do you have a Discord? Yeah, so let me register, or let me send it to you. Sorry, I really need a bot. This is the course that we do for malware analysis. You can just register, and then there is a Discord link. I just put it behind a registration because I'm worried about bots and spammers and stuff like that. But we won't spam you or anything, for the record. But yeah, if you're interested in learning malware analysis as well, you can check that out. Cool. So let's go back here. Okay, so it's looking for files. And then, so it looks like it's recursively enumerating directories within a drive. And then looking for these HTTP upload directory stuff. Hold on. Okay. Probably have to change that file name later, which is fine. Okay, then it's looking for EXEs. Malware analysis is something I'm interested in, but not now. But I have in mind if asking your community questions about a project. Yeah. If you just register, then you can access. I'll just give you the Discord link. Hold on. Okay, let's keep going. So we get the full file path for these. So these look like they're related to HTTP servers. No, it's not a distraction, don't worry. Yeah, this is ASP.NET stuff. So, let's see here. So if there's a .exe and those ASP.NET paths, exe extension. So this is that read attribute, I think, again. Hey, Matt. Yeah, I'm probably going to do every second Saturday going forward for the time being. Yeah, El Matos, yeah, IIS, exactly. I want to stream more. I'm just trying to figure out what times work best. So 2 Saturdays from now, I'll probably be streaming. Okay, get sent path. Self file name. Okay, so it looks like it's copying to temp, setting the read attributes, then opening the file. Okay, I think it's just appending random bytes. So, yes, and then it's printing into the stream. So malware will often change its own hash using a technique like this. Basically, it's copying like pseudo-random bytes to the stream, or to the file stream, and that will change its hash. So, like old antiviruses would literally just like look up SHA-256 hashes of malware and stuff. Maybe that's wrong. I think this is just generating a temp file name. Yeah, so it's just looking for, no, but it's copying to the stream, I think. Sorry. Okay, I'm pretty sure it's, yeah, no worries, El Matos. Yeah, I've never used XVI. Is it any good? Okay, then it's looking for zip files. And then, man, this thing is nasty. It's basically replacing a bunch of HTTP server files with itself. How is this valid though? Like if it just makes a, so this is the zip file header. Can it actually just, is it actually just that easy? So it's creating a malicious zip file, copying that too, and then it does the same thing with RARs. It's simple because you could search, for example, this program, then find the MZ using the delete cursor, boom, you could clean the file. Yeah, that's basically what I was doing with HXD, but like deleting all, there was like thousands of bytes before it, so I just thought it was faster with Python. Okay, so enum fixed drives for zip exe rar replace propagate worm. Let's just say something like that. So it's kind of funny is like this will basically replace a bunch of files on IIS servers with itself as well. Okay. So okay, now it's grabbing clipboard data. I know what it's doing. Do you all know what this is? What could it be doing with the clipboard? Sorry, I'm just gonna eat some more granola bar. What's gone up in price a lot lately? Yeah, exactly. Mad Depp. I think it's changing crypto addresses. Yeah, let's do it. After I reverse this, I'll check the wallets. Okay, so so what I was alluding to, and Matt Depp pointed out, is there's a lot of these. There's some buzzwordy term for it now. It's like clipboard hijacking or clickjacking. No, not click. No, that's wrong. But clipjacking. But basically, what's happening is it will monitor the clipboard for contents that look like cryptocurrency addresses. And then if it sees, so this is like a whole heuristic, right? So it's checking, so let's back up here. So open clipboard, get clipboard data. Then it has, cool, awesome, Musa. Yeah, even if, I know you said not right now, but there's like a few free modules if you just want to check it out. All right. Yeah, so is alpha, is digit, and then these are the start of various cryptocurrency addresses. So if it's a 1 or a 3, then it replaces it with this address. I don't know if there's, I wonder if I can find something online to like identify types of cryptocurrency addresses. Because I used to think that Bitcoin started with BT, but do you guys know how I can find out what kind of cryptocurrency addresses each of these are? Yeah, so Matt Depp was right. They are opening the clipboard and then setting the clipboard with this copied address or with this copied data. And basically that's just the length. So length of crypto address. And then we have the address string. That's just the global lock. So, all right, so let's see. USA's looking too, but I'll also look. Cryptocurrency address identifier or something. Type identifier. Cryptocurrency address formats. For example, you can send BTC from an address that starts with a 1. I know, but is there like consistency? 1, 3. Oh, BC. This is the one I was thinking about. So this is probably a 1 or a 3 is probably Bitcoin. I thought there'd be like a list for this. Maybe it's harder than I think. Cryptocurrency address detector. Bitcoin always, yeah. I don't want to npm install this. But this is kind of what I need. So this is a website. I just want a website to do exactly this for me. Block Explorer. Oh, cool. Perfect. All right, I think we're good. I'm pretty sure this is Bitcoin. Yeah, Bitcoin. Total received 5 Bitcoin? Are you serious? Holy moly. Oh yeah, should I use ChatGPT? Oh, actually I could use, oh, I think I can only ask it code related questions. Oh yeah, I have a really good blog. Well, I should say really good. I have a really big blog on all the binary ninja stuff that I did over the past few streams that I'll be putting out too. I asked it for a table with different cryptocurrency addresses and how to identify them. Oh, cool. Can you throw that in the Discord, Duncan? just like anywhere. Oh, cool. Okay, let me. I don't think I'm logged in, but can I just like see this? Oh, sick. Okay. Base 58 or B. Okay. This is perfect, I think. Take care, Wusa. Thanks for hanging out. Yeah, no problem. All right. So yeah. Oh yeah. I was occupied by my mind being blown because like, what is 5.8 to USD? Like that's $60,000. Wait, no, it's more than that. It's like hundreds of thousands of dollars. Hopefully they held on to their Bitcoin. Okay, so Bitcoin. I think this is, I don't know what T it would be. I don't think that was in the table. Yeah, that's actually mind-blowing. But if they held onto it until now, which, who knows. Okay, that didn't work. T1. Or wait, I don't know. Or it starts with a Z. Maybe it's like I know Z address. Ooh, Z address Bitcoin. Or wait, cryptocurrency. Yeah, Zcash. That's what I was thinking of. Zcash. I'll see if I can look up the Zcash address actually, because it looks like Blockchain Explorer. No Zcash. I think this is Litecoin. Are they just trying to replace the address with something that starts with the same? So basically they're looking for cryptocurrency address formats. And then, so this would be the scenario where somebody's like moving crypto, they're sending crypto to a specific address and then they replace it in the clipboard. So this would be if like somebody copied their destination cryptocurrency address and they replaced it with their own. So I think that's basically what you're saying. For Litecoin too. Crazy. I don't know what this is, but trade $60. Still pretty good. I don't know what this one is. Alright, we probably don't have to go through all of these, but still cool. Did he start with 4? No. Yeah, let's finish this up because probably only going to stream for like another hour and a half. And I think before I go on to the next for the next function, the next thread function, I will run to the washroom again. So I will be right back. And also, I don't want to shill too hard, so I apologize if this is getting annoying, but I'm just going to run another commercial, and then there's also a discount code that's on the Be Right Back screen, so if y'all are interested. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, I'm back. How's everybody doing? All right, so I think all that's left for us to look at is the command and control functionality. So let's take a look at that, and then we'll be done. So this is the last thread that's run in the background using create thread. So WSA startup. So this is all like Windows HTTP stuff. So function initiates a WinSock DLL by process. Initiates the use of a WinSock DLL by process. So we'll just say WSA startup is fine. And then it initializes the SRAND again. And then we just have 256 iterations of every third index being zeroed out for some reason. I don't know what this is for, but we'll see. Oh, this is your assigning D words. That would make more sense. Yeah, well, that's fine. Zero globals. All right, and then we have CP here. So this points to the top of the command and control pointers. So if we have, we have an IP address here, right? So let's just say IP pointer, because I think the domains are referenced down here. Oh, maybe not. Okay, let's just say C2 pointer table. So the reason I call this a pointer table is just because each of these C2s has a pointer to it. I'm not entirely sure what. Oh, these might be ports, but we'll see in a sec. See how it's a string followed by 50/50. Okay, so then this resolves the host name using getHostByName, and then it's creating a socket to that host. So this SA data structure is basically just setting up an IP address context, and then it switches the IP address to network byte order using this h2ns function, and it creates the socket. So this is, okay, so this is the port pointer table. When I said that was the host earlier, I meant that was the port. So h2ns is used for the port, not the IP address. Sorry. And then we connect to that host, and then the sockets returns. So we already have all that marked up. Say CI current index. Call this sleep. Okay, and then looks like we're gathering some information in this function, and then doing some format string stuff. Okay, so let's go back here. Okay, so this is that locale data call that I was talking about earlier. So we get the Win Manager text file. From app data. And then we concatenate it with the backtick for some reason. All right, see you, Duncan. Have a good one. Have a good night. Okay, so it's getting the locale. So let's see what this is doing. So the LCID, let's see what LCID is getting. The system default, what? Sabrev. I don't know what that is. Good constants, Microsoft. Oh, abbreviated name for the country or region. Okay. Okay. Okay, and then it's concatenating. Okay. Or wait, let's say get locale with 8 rand bytes or something. I don't know. All right. So I'm just marking up each area that's used. So, okay, so we create the socket. We pass that to this function with the locale and then the character X. Okay. And then we go to this function. We have the socket. We have the locale. And then we have, I think this is just if this succeeds. So then we have the locale, socket, something, locale, something. So socket, something, locale. Okay. And then we have the user. Oh, does anybody know what these commands are from? Yeah, IRC. So there's an IRC bot. So we have the user command. So for those of you who are younger, this is like Discord, but more ghetto. Because it was all just text-based. This is what we all used before Discord and Slack and stuff. All right, yeah, so we can just do, oh, and then we have, okay, so this Boolean is probably mapping to Discord Grandpa, yeah. Which tells you how old this malware sample is. So we have a socket, then we have the locale string. Sorry, I'm drinking a bubbly, which is like a terrible decision because keeps making burp. Okay. So we have, okay, let's see what this Boolean does. So we have the case statement. Okay, so this is command type. Command type. So the IRC command type. And then we have the socket, and then we have the locale string. Yeah, exactly. And then we have, looks like an optional message. Okay, and then that's used a whole bunch of places. So I think this is probably doing a check-in because it's the first one that's called. So 0 case 0 doesn't have a case. So it returns 0. And then the first command is a user command. Damn, still going strong. Yeah, I think, I don't know, I'll probably be done kind of soon here, but what's going on, Everest? I don't remember any of my IRC commands, so nice. What sample are you reversing? Okay, so it's just user command lets the user set their username. So okay. And then ping pong join. Funny enough, mine also uses IRC. Nice. Okay, cool. So we have the IRC check-in. Then we have select, which is a timeout. What does select do again? Oh, nice. Okay. Yeah, I'll check it out. Oops. I don't want to select select, okay, yeah, check status. Cool, okay, yeah, I'll check it out. The auto mod bot just flagged that for me, the unpacked.me link, which I thought was kind of funny. Okay, so this is parsing the response using recv. So this is IRC response, and then checking if it has 001. So these are probably custom commands. So if it's 001 hashnet hash, 3 is join. Okay, nice. So this is join channel. So specified channel. String token space. What'd you have for dinner, Everest? Actually, maybe don't tell me because I'm starting to get hungry. Okay, so then it's comparing the string token. Space tokens. So if there's an at, then space. Okay, and then we do a ping, or no, it's checking if it's a ping, and then if it's a ping, then we do a pong, right? Yeah, do pong. And then if the string, okay, so if it's a 443 command, then we do then we give the locale with 0. Oh, if it's not, sorry, if it's not 443, then we do a private message. Oh, cool. Thanks, Everest. So we do a private message. String character at string compare to x. (332) string not compare. Okay, hold on. What was the if not string copy? No, I think these are the string compare gives an index, right? And if they're equal, then it would be 0. So yeah, so okay, so equals 0, yeah. Otherwise, we compare it to a private message, copy message. Okay, otherwise if it's a 332, then what do we do? String copy by move, copy message. I don't know what TRK is, but RMRF. Okay, so this is probably, yeah. So, okay, so this processes the private message received from the bot operator. And if it gets an RMRF, then it deletes. And then if it's a SL, string compare, if it's an SL, then it gets the locale data, then checks if it's a admin or a user, then gets the, what is this? See, I should be able to get the CSIDL. I know these are like enums, so it's probably just like a part of this. Oh, this is probably program files, yeah. So just based on this string, if it has x86 in it, malware check get okay. So if it's SL, then it sends a username with the locale. I'm gonna see if 2A is profile. Yeah, nice Matt Depp. Those are two different patterns. Yeah, so 802A. I see what you're saying. Okay, nice, thank you. Otherwise, if string comparison is a J, then it does a join. Oh, maybe this doesn't send the locale, it just does a join. No, this is doing a join, sorry. Join channel with locale and custom name. So I'm assuming every bot has a channel. D gets the, let's see. Okay, there's another decryption. No, it's not decryption. While, I'm not sure what algorithm this is. I'll take a look at that in a sec. I was wondering why there was no C2 column encryption. Yeah. I think this encoding makes it like not plain text, but I think this might be base 64. 0 to 9. No, it's not, never mind, because it doesn't have the alphabet. Yeah, it looks like this is some encoding format. For a, not one that I recognize. Let's see. So I was messing around with Binary Ninja's sidekick, and it's pretty good at like identifying arbitrary algorithms. So I kind of want to see if it can identify this. Oh, cool. Okay. So this also has loader capabilities, probably. Let me double check, or let me confirm that before I just make things up. Find path file name, string token. Okay, so these are those zeroed. Yeah, so this is downloading and executing another payload. And or this, I think this might be an update mechanism actually. Yeah. If not 13, what sets this? Okay, so I think it tries to, for some reason it checks if the process name of the downloaded executable is already running using that process enumeration stuff earlier. So like, or I mentioned earlier, so create tool help 32 snapshot will enumerate all the processes in memory. And then for the file name of the downloaded file. And then if it does exist, then it generates a random file name to download the file to. But it looks like download execute file. So based on the parameters, if I'm understanding them correctly, it checks if there's that's the algorithm we don't know yet. So I'll double check that one. So if there's the download command D, and then this is number of parameters, I think, from IRC command. So there's the download parameter D, then it gets, then it decodes the URL, the download URL, I think, and then it parses X and U. And then if it has those, where's this, an OR? No, it's an AND. So if it's an X and U, and then I'm assuming that encoding will decode a download URL, and then it downloads the file using internet read file and executes it using that function that I was just looking at, the MW download execute file. So yeah, that's kind of it. I'll probably write up some notes on how exactly this functions, but pretty straightforward. IRC bot that can, oh, this is CRC32 for sure. What's using CRC for? Sorry, I'll go through these last functions and then we can probably finish up. For rar. Oh yeah, let me see if I can get Sidekick to tell me what this is. Hey, cat peasant. I like your name. All right, let's see if I can, I don't know if I can just straight up ask it like, I should really just use ChatGPT, but maybe that's the wrong way to use it. Oh, is it RC4? I don't think so. Is there 256 rounds? Nah, I think it's wrong. Because there's multiple XORs. Anyways. So yeah, kind of cool. Little clip jacker. I think those are pretty good. Wait, I should be able to mark these up. Oh, never mind. Malware receive. IRC response. Is this like made or something? Oh, nice. Okay, so the way I know this is CRC32 is because of this constant. So that's always present in CRC32. I already marked that, so this should be already. Okay, so that's related to the zip file stuff. Oh, nice. So this is setting the system file time of, again, zip file stuff. Cool, so that's, sorry, I'm just making sure that that's actually all of them. Cool. Yeah, so we've pretty much reversed this entire thing. So an IRC bot that can receive multiple types of commands. I think its primary goal is obviously clipjacking and to be able to download other payloads. If we were to like write a report on this or what have you, we'd probably want to extract all the indicators of compromise to look for them in the environment. So all of these different C2s that can be leveraged as like backup. So I'm assuming this was a malicious IP address at some point. And then you have all of these command and control servers that are being used for IRC command and control. The other thing that you could look for too, oh, it looks like this. Oh, cool. Okay, so what's whip mania? Is this another? Hold on, I just want to see if there's an actual website. Okay, so it's a GeoIP database. Okay, so it looks like they're also, let's see here. Okay, this just might be testing internet connectivity or something. But basically, this website is used for geolocation, IP address geolocation data. So what I wanted to see is if we can see this running in action. Any possible geo restrictions? I don't think so. I was checking. That was a good question though. So I don't know if this will detect that it's running in VMware, but I think it'd be cool to see the the IRC command and control in action. Do we have IRC in? There must be IRC in INetSim, no? Or oh, I think we can do it. I don't even think we need our little endpoint box here. I think I can just do it with. So I'll just double make sure that I don't have any shares mounted because this is actually like writing and messing up shares. So if we do something like fake netng And then before I infect this computer, I'm just going to take a snapshot because I want to save that IDA database because it was quite a bit of work. Yeah, hopefully no anti-emulation, if that's how you meant, Josens. Yeah, I just take snapshots all the time. And then I'll have like snapshot purge days where I'll just like delete my gigs on gigs of snapshots. Okay, so next thing we're gonna do is, yeah, it's very good advice, Josens, to save everything. All right, so hold on, I actually want to make sure. Hold on, I'm just gonna make sure that there's no USB devices mounted either. I'm pretty sure there isn't, but yeah, cool, there isn't. All right, let's see this thing go. I think FakeNet has IRC, right? Well, let me make sure this is actually working. Yeah, Josens, it's propagating, or it has USB it has like every type of propagation. So I just want to like triple check everything. Why isn't FakeNet working? Failed. Starting FTP server. Failed to notify adapter change. Why is it failing? Okay, maybe I will use my other machine because I know that works. We need, yeah, it does IRC, nice. And then what were they using? 50/50. And then let's make sure DNS and stuff is responding. No, not that machine, the other one. Okay, cool, that's working. Oops. All right, we should see the IRC columns come across if I did everything right. I don't know why we're not seeing comms right now though. Okay, cool. It's just quiet. I think the carved PE should run. All right, is it running now? I might have detected VMware. Let me see if I can deal with the anti-analysis. Did it self-delete? I think it did. Crap. I need to restart the snapshot. But that's why you have snapshots. It should be running though. Whatever. Let's restore and see what happens. Yeah, so it probably detected the VM if it deleted itself. Uh-oh. I didn't mean to double click it. It just did it again. Fail. This is why you shouldn't ever do malware analysis on a host, because you'll just self-infect yourself. Okay, do this nice and easy. Okay, and then we'll break on the anti-analysis stuff. Yeah. But this should be working. All right, why are the comms not working now? Oh, it's because FakeNet. There you go. Okay, why is NetSim not working now? Sorry, one sec. Should there be DNS on here? Yeah. It was, yeah, it wasn't flush DNS. It was because of, FakeNet NG. It changed the IP. Now it's working. All right, let's see if I can not screw this up. we have VM. So this one. Okay, so basically I'm just going to set a breakpoint on that anti-VM check. And it's not, I need to rebase this as well. I'm going to do another snapshot because I don't want to do all of this again if I do miss it. All right, now I'm going to snapshot. I really need to harden this VM so I don't have to do stuff like this. All right, I think we're ready to go. So let's see if the response jump is, okay, jump is not taken. So it was indeed the anti-virtual machine analysis stuff. So let's see if, I think that was the only, I think we can just let it rip now and see what happens. Okay, we should be getting comms now. Hold on, I'll capture on all. What? Maybe there's something else. I don't know if there's any other anti-analysis tricks, but where did we say that was writing itself to? All these different directories. CD. Okay, not there, but it created the directory there. Unless it said that hidden directory attribute. Winver. Okay, let's try that again. If it's not meant to be, it's not meant to be, you know? This is why we do everything statically, so we don't have to worry about it. But I would like to see the IRC traffic. That'd be cool. Maybe we can skip over that part. So I'm just going to set a breakpoint on the copy file. Okay, so I'm just 523C. Okay, so it's copying to the Windows directory. Oh, maybe it's because this. All right, let's just keep going. All right, so I'm going to force this jump so it doesn't like re-execute itself and do, hey, oh, friends, how's it going? And by oh, friends, I mean friends. We're almost done here, but we were just getting this IRC bot to talk to our IRC command and control. But yeah, I'm just going to skip over all of this setup that it does for the persistence, etc. All right, so then we should get the threads called now, including the C2 thread. So then if we go back, okay, so we're seeing the traffic. Yeah, can Wireshark not parse IRC? Cool. It's okay, don't worry. Everest, this is basically just what I wanted to see. So, yeah, sure. Here, I'll give you the hash. I gave it at the start. Oh, I don't have it up still. Yeah, I already got the stream. Here's the malshare link, friends. So yeah, like the next step would be for us to emulate them downloading, or like us responding with a command and then getting the bot to do stuff. But probably save that for another day since we're at like 5 hours. So yeah, I'm just gonna run one more ad, and I'll throw that coupon code in the chat. If any of you want to check out the course, you can get it for the student discount amount. One sec. Thanks, Matt. Glad you enjoyed it. Hold on, let me get that code. Yeah, I'll play the ad 1 sec. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, so if any of you want to check that out, the coupon code is beginner RE 2024. Yeah, Franz took the course and now has his certification, which is cool. But yeah, thanks so much. I'll post the recording on our YouTube channel. I'll post that too. So yeah, the recording will be up there this week, and I'll see y'all in the Discord. Thanks so much for joining, and I hope you enjoy the rest of your weekend. Take care.